everybody! I hope you're all having a great 2018 so far and had a happy new year. I apologize for the long hiatus since my last talk went up. Between some health issues in my own family, the holidays, and some technical difficulties, it's been too long. I'm hoping to make up some ground with some new talks in the next coming weeks. Today's topic should be pretty current since we're still well in the midst of a terrible flu season here in the Northern Hemisphere. I think all of us have seen more than our fair share of flu patients in the last few weeks to months. Influenza is a disease that has plagued human society since the beginning of recorded history. But all of a sudden, just in the last 2 decades, we have a pill that supposedly treats influenza. The question is this a big deal, or is it just big money? Since it's a new year, I need to do my annual disclosures, and sadly, I still don't have any financial conflicts of interest to report, so I guess I'll just keep on working. That being said, I do have some pretty strong opinions that are going to impact today's topic. I don't hide the fact that I have very little respect for the current practices of Big Pharma in the United States. With their ongoing shenanigans with outrageous drug pricing and their history of withholding important data to make a drug look more effective or safer than it actually is, I freely admit that I have little respect and, frankly, some contempt for the industry. I'll try and keep this talk purely objective, but it's only fair that I admit my own bias. Despite the fact that it happens every year, the flu is always big news. Some years bigger than others. And the reason we're talking about this today is because, unfortunately, during flu season, no matter where you live, you're going to see some headlines like this one. This is basically doctor bashing, and it implies that if we had only given this poor mother the magic flu pill, that she would be alive and raising her 4 children today. But then, you see stories like this published the next day. And now we have another tragedy. Only in this case, the poor doc is being blamed for prescribing the stuff. For a drug that gets this much hype and attention, there is shockingly little good quality data to support its use. For the next 30 minutes, I'm going to quickly summarize the best data that we have on this, but we'll also talk about why this is such a controversial topic and wrap up with some suggestions on what a poor clinician is to do. Influenza has been described in writings from the earliest civilizations. In fact, Hippocrates himself described the flu syndrome in 412 BC. There have been many more recorded outbreaks and pandemics throughout history that are thought to be due to influenza, with the worst pandemic in modern history being the Spanish flu that occurred about 100 years ago, resulting in the deaths of 60 million people worldwide in a single year. In fact, influenza is second only to smallpox as the virus that has killed the most humans throughout history. Most of us have been practicing during the more recent concerns swine flu and bird flu, but fortunately those did not turn out to be as deadly or as virulent as the strain that we had in 1918. Influenza spreads around the world in a yearly outbreak, resulting in about 3 to 5 million cases of severe illness and about 250,000 to 500,000 deaths per year, with the majority of deaths occurring in the old, the young, and those with underlying comorbidities. In the U.S., the annual influenza season, including the costs of medical care, lost wages, and lost productivity, is estimated at about $10 to $20 billion per year. Influenza A viruses are classified into subtypes according to the combinations of the hemagglutinin and the neuraminidase proteins on the surface of the virus. This is where the H1N1 or the H3N2 classifications come from. Neuraminidase is a protein that disrupts cell membranes of infected cells, releasing new virions which are then spread to infect other cells. Considering its history and the costs, it's only natural that we would very much like to have a drug that works for the treatment of influenza. Oseltamivir is a neuraminidase inhibitor, which theoretically is supposed to prevent the release of new virions and limit the spread of the virus. Sounds good, right? Enter Roche Pharmaceuticals, the company that brought us oseltamivir. During the 1990s, Roche sponsored 40 clinical trials, but only 2 were published in peer-reviewed journals, and data from 8 additional others were presented at various congresses around the world. Many others weren't. As you might guess, they handpicked the studies that demonstrated a treatment benefit, but also didn't really spend much time examining the harms of treatment. The remaining data from the other trials was sealed and kept out of public view by Roche. Oseltamivir was approved by the FDA in 1999. Over the next decade, this drug was widely prescribed and even stockpiled by governments in the event of a flu pandemic. Since its approval in 1999, it has generated an estimated $18 billion in revenue for the pharmaceutical company. However, reported adverse effects were also starting to roll in, particularly from Japan, where they have a much more robust system for reporting adverse events than we have in the United States. They were noticing psychiatric disturbances and some deaths, especially among children taking the drug. Ultimately, this earned oseltamivir their equivalent of our black box warning. Over concerns regarding adverse effects, in 2009, the Cochrane Collaboration attempted to undertake a review of all of the data concerning this drug. It wasn't until 2013, and after a lengthy legal process, that Roche was finally compelled to allow access to the previously sealed data, which was then analyzed and published by the Cochrane Collaboration. Major props to the Cochrane Group for doing this. The data they looked at included about 150,000 pages of clinical trial data that they had to collate and sift through. So this was truly a Herculean effort. This month, for our mental breaks, I'd like to offer up scientific proof that cats are in fact a liquid. A liquid is defined as a substance that lacks definitive shape and assumes the shape of its container while maintaining constant volume. So that's it. Cats are a liquid. Since we want to review the evidence published regarding the efficacy of oseltamivir, we're going to do the rest of this talk journal club style. Our clinical question is, in patients with acute influenza presenting to the ED, does oseltamivir improve time to clinical alleviation of symptoms or reduce the rate of serious complications related to influenza, including hospitalization, pneumonia, death, and so on? The reference is a paper published in the BMJ in 2014 and is a publication of the data produced by the Cochrane Collaboration's analysis, and the analysis includes both previously published and unpublished data. Let's do our Piko question. They screened 83 clinical study reports and found that 23 had complete enough data for analysis. So this review includes 23 randomized controlled trials, including both adults and children diagnosed with acute influenza. 4,552 patients were included. However, not all outcomes were studied in all patients. The intervention was treatment with oseltamivir, whereas the comparison was treatment with a placebo. It's worth noting that the placebo they used in several of the papers contained dihydrocholic acid, which unfortunately is well known to cause GI distress and vomiting. The outcomes were the time to symptom relief, need for admission to the hospital, and the frequency of complications or harms as a result of treatment. Now, let's quickly run through our quality checklist so we can decide how good the data in this meta-analysis is. Was the clinical question sensible, clinically relevant, and answerable? Yes, it was. Next item, the search for studies was detailed and exhaustive. Again, yes, it was. Next question. The primary studies were of high methodological quality. Nope, not on this one. There was a high risk of missing data regarding symptoms, and there was selective and self-reporting of many of the influenza outcomes they were trying to measure. Things like pneumonia and alleviation of symptoms differed between the papers. Only about half of the studies were adequately randomized or blinded to the patient, and only about 2/3 of them did a good job of concealing what group the patient had been randomized to. And if you remember, we mentioned before that the placebo some of the studies used tended to cause GI distress, so it may have been clinically apparent who was in what group. Did the authors tell you how they did the systematic review so that you could do it again if you wanted to? Yes, they did. Was the outcome clinically relevant? Yep. Next, there was low statistical heterogeneity for the primary outcomes. Unfortunately, this is another no. Across the papers included, the definitions for the things they were trying to evaluate were often different. For example, was it pneumonia if the patient said it was on a survey? Or if the doc auscultated RALs on exam? Or did the patient have to have a positive chest x-ray? And what exactly was the criteria for alleviation of symptoms? So there was substantial heterogeneity. And lastly, the treatment effect was large enough and precise enough to be clinically significant. This one gets it's unclear. Some of the findings were statistically significant, but whether or not they were actually clinically significant is going to depend on your point of view. And here we have further proof of the liquid state of cats, in this case being demonstrated by the cat-Bernet variety. So what were the results of the analysis? It appears that there is a statistically significant reduction in symptoms of about 16 hours in adult patients with influenza and about 8 hours in children. However, taken in the context of an illness that usually lasts at least 10 to 14 days, feeling better half a day sooner doesn't really seem all that clinically significant. Interestingly, when they looked at children with asthma, this reduction in time to symptom relief was not present in this subgroup. Unfortunately, it seems that treatment doesn't do the one thing we really want it to do: reduce the complications of influenza, like the need for hospitalization or the development of pneumonia. Interestingly, when you look at the data regarding pneumonia, many of the studies never actually verified that the patients who reported pneumonia actually had it. They did things like send out a survey or just ask the patients, "Did you think you had pneumonia?" as their criteria for diagnosis, which means this data is next to useless. When you look at the trials where they used actual clinical criteria, like findings on pulmonary auscultation or chest x-ray to confirm pneumonia, there was no difference. What about the harms of treatment? The patients that were treated with oseltamivir instead of placebo had almost twice the rate of nausea, more than twice as much vomiting, and 25% more headaches. It looked like oseltamivir may have decreased diarrhea, but if you remember, earlier the placebo they chose contained dihydrochloric acid, which is well known to cause diarrhea. So they picked a placebo that probably gave the control group the raging sharts, which was one of the side effects they were trying to measure, and that's called an epic placebo fail. It looked like there were fewer adverse cardiac events, such as myocarditis and pericarditis, but that also came at the cost of increased QT prolongation, so you may want to make sure that you aren't giving this drug to patients that are on other agents that already prolong the QT. Have you ever seen a patient coming in floridly manic or psychotic after being treated with oseltamivir? I have. Most of the studies done did not report outcomes on this, and much of what we know actually comes from post-market surveillance data. There does seem to be a dose response to this, with more severe effects occurring at higher doses. There was one trial that reported a significant effect in patients that received prophylaxis, which means they were giving asymptomatic people a drug that made them crazy. There have been some concerns raised because there have been a few patients that completed suicide shortly after taking this medication, and it's unknown what the impact of this drug is on patients that have underlying psychiatric disease. The vast majority of the data we have on this drug involves treating outpatients, since the majority of patients who get the flu are managed as outpatients and ultimately do fine. But what about patients sick enough to require admission, and those who are critically ill? Unfortunately, the only data we have on this population of patients comes from small observational trials, as there are no randomized controlled trials comparing neuraminidase inhibitors to placebo in critically ill patients. Overall, the quality of the evidence is very low, and there are a great many confounders, as factors like immunization status, how sick they were when they were enrolled, the presence of comorbidities, and so on, could not be controlled for in the majority of these small observational trials. Overall, the data suggests that there might be a survival benefit to treatment if it is started within the first 5 days of illness. However, it does not appear that using supranormal doses has any survival benefit. It also seems that these patients tend to do better if treatment is started early. In this population, frankly, there's probably little downside to treating. Really, if you're going to treat anybody, this is the population where we really would like a treatment that works beyond care. Frankly, if you're intubated and in the ICU for a week, the cost of a course of oseltamivir is trivial, and the side effects aren't going to be much of a concern when you're on a ventilator. We've established that cats can live in a liquid state. What's even more amazing about cats is that they have the ability to transition from the liquid to the solid state, as demonstrated by this picture. Now, let's look at the treatment recommendations from the CDC and from the FDA. The CDC's director has made statements to the effect that oseltamivir saves lives, despite the fact that we have no good quality evidence that demonstrates this. According to the CDC's recommendations, antiviral treatment is recommended as early as possible for any patient with confirmed or suspected influenza who is hospitalized, has severe or complicated illness, or who is at higher risk for influenza complications. Being at, quote, higher risk for complications includes patients under the age of 2 or over the age of 65, and basically includes everybody that has had any clinical diagnosis other than having a pulse. I'll put the list up for you in a second, and if you'd like to pause the talk and read it, you can, but I won't torture you by reading it to you because it's quite extensive. They also suggest that you consider antiviral treatment for any previously healthy, symptomatic outpatient not at high risk with confirmed or clinically suspected influenza if treatment can be initiated within 48 hours of illness onset. However, the FDA is less enthusiastic. They simply state that this drug has been approved for the treatment of influenza, but have also made official statements that oseltamivir has not been proven to have a positive impact on the potential consequences of seasonal, avian, or pandemic influenza. I'll put up that list now if you'd like to pause the talk and review it. So why the disconnect between what the CDC and the FDA say? As with most of these things, all you have to do is follow the money. Most physicians believe that the CDC, as a government agency, is free of industry bias because the CDC does not accept funding from industry, at least not directly. But here's the dirty secret. The CDC Foundation, which accepted over $86 million in donations in 2017, is a nonprofit organization that filters corporate money to the CDC. The CDC Foundation website describes this as, quote, forging of partnerships between the CDC and corporations. Since 1995, the CDC Foundation has formed relationships with over 150 corporate partners, many of whom provide donations in the form of conditional funding, which basically means that they are giving a sum of money to be used for a specific pet project that will promote their agenda. In 2014 alone, the CDC received $16 million in conditional funding. For example, Roche Pharma, who just happens to be the maker of oseltamivir, gave the foundation a grant of almost $200,000 to support the Take3 campaign, step 3 of which was to promote the use of antiviral drugs for influenza. In addition, Roche, Gilead, and Genentech, each of whom have some ownership in the production of oseltamivir, also contributed undisclosed amounts in addition to the Take3 campaign. If this slide made you squirm a little bit, you're not alone. It made me squirm too. Doing the research for this slide was frankly a little upsetting and makes me wonder if I can take any of the recommendations from the CDC at face value. The biggest argument I always get from people when presenting this talk is because of this paper. This is the paper that the CDC cites for all of its recommendations, since this is the paper that says that there was a benefit in symptom reduction and in a reduction of complications. But here's why I don't buy what these authors are selling. This multi-party group for advice on science foundation sounds pretty legit, right? Nope. The money came from a grant from Roche Pharmaceuticals. How about the authors? 3 of the 4 authors are on the payrolls of Roche, Gilead, and Genentech, who just happen to be the 3 companies with an interest in the production of oseltamivir. And lastly, this paper failed to publish their statistical methods, so we don't know how much statistical jujitsu they had to do to produce their results. Granted, that doesn't necessarily mean that the data in the paper is wrong, but since its approval, this drug has generated in excess of $18 billion in revenue. So for the drug companies, there are 18 billion reasons to keep this going. So how do you take all of this data back to the bedside? For what it's worth, here's my take on it. For the most part, oseltamivir probably doesn't do that much, and there probably is no benefit to treating outpatients. There's not good data to support its use in the inpatient or critically ill population, but what little data we have does suggest that this population may see a survival benefit. Because of this, if you're sick enough to go to the ICU, I'll go ahead and give the drug. And really, what's the cost of a course of oseltamivir in light of the cost of several days in the hospital? For flu patients that are well and be treated as outpatients, I encourage them, first of all, to get their flu shots next year. Having the flu sucks, which makes this a very teachable moment. Second, I recommend all the usual flu symptomatic treatment. You know, acetaminophen, ibuprofen, tea with honey, all the stuff that Graham had figured out long before we had to figure out what to do with this drug. Lastly, I do shared decision-making with the patients. I tell them that this drug that is supposed to treat the flu exists, and talk to them about the potential side effects, and let them know that the best data we have to date shows that this probably won't reduce the potential for complications, and will get them better about a half a day sooner, and that it's going to cost them about $150. For some of my patients, that's a significant chunk of their disposable income. To a few, that half day they might be able to go back to work is worth it to them. But I find that the overwhelming majority agree that getting better half a day faster is not worth the price tag or the doubled incidence of vomiting. For the most part, I find that patients are grateful to be included in the decision-making process, and they feel empowered by having a voice in their own care. Let's wrap things up with a couple of take-home points. 1. Oseltamivir shortens the duration of illness by about a half a day. Whether or not this is clinically significant is a decision for you and your patients to make together. Number 2. Oseltamivir does not appear to reduce complications of influenza. Number 3. There may be a mortality benefit in the critically ill. However, the evidence supporting its use in this population is of very poor quality, and better studies are needed if we're going to figure out if there really is a benefit in these patients. Lastly, there is a very clear financial conflict of interest affecting current guidelines. Ultimately, it's up to you to decide what to do with this information. Well, that's it for this talk. I hope you found this review helpful, and I'll see you next time. Stay healthy, and remember to get your flu shot.